Hello everyone. Welcome to the second hour of Newton's laws of motion. In this hour, we will talk about connected bodies, constraints and equation along the string. So watch the lecture carefully. So first of all, let's talk about connected bodies. Let's think of a system of two masses of a block of 5 kg and another block of 3 kg. On this whole system, we have applied a force of 40 Newton. Since both of them are constrained to move together with a common acceleration, we can think as if we do not have two different blocks. We can think as if these two blocks are welded together and the whole system has a mass of 5 kg plus 3 kg. So we can treat this whole system of 5 kg and 3 kg block as a rigid body of total mass 8 kg. We can say that the acceleration of the system will be equal to the net force acting on it upon the total mass of system. The net force acting on this system is nothing but 40 Newton and the total mass of system is 5 kg plus 3 kg. So we get the acceleration to be equal to 40 upon 8 and 40 upon 8 gives us acceleration of 5 meter per second square. So both the blocks will have a common acceleration of 5 meter per second square towards right. Now comes the next question. What will be the normal force applied by 5 kg on 3 kg, let's say N, and what is the normal force applied by 3 kg on 5 kg, let's say N. We know that the normal force is a contact force. The normal force is pushing in nature. So 5 kg block will push the 3 kg block towards right and the 3 kg block will push the 5 kg block towards left. To find the magnitude of normal force, look at any one of the block. Either look at the forces acting on 3 kg block in the horizontal direction or look at the forces acting on the 5 kg block in the horizontal direction. Let's find normal using both the methods. Let's see the forces on the 3 kg block. To find the normal force by 5 kg on 3 kg, look at the forces acting on the 3 kg block. In the horizontal direction, only one force is applied on the 3 kg block. That is the force of normal by the 5 kg block. Do understand, the force of 40 Newton is not at all acting on the 3 kg block. The force of 40 Newton acts on the 5 kg block and the 5 kg block applies a normal on the 3 kg block to move it forward. And we know that the acceleration of 3 kg block has to be 5 meter per second square. So by using the expression that the net force in direction of acceleration equals to mass into acceleration, we can say the net force on the 3 kg block is only the force of normal. It has got a mass of 3 kg and the acceleration is 5 meter per second square. So we can say N equals to ma, that is equals to 3 into 5. Hence the force has to be equals to 15 Newton. So the force of normal by 5 kg block on 3 kg block has to be 15 Newton. We can find the same value of normal reaction just by looking at the forces on the 5 kg block. If you look at the forces on the 5 kg block in the horizontal direction, you will say on the 5 kg block, an external agent applies a force of 40 Newton towards right and a normal reaction is present because of the force by 3 kg block on the 5 kg block. We can say the net force in direction of acceleration equals to mass into acceleration. Net force in direction of acceleration equals to mass into acceleration. The net force on this 5 kg block in the direction of its acceleration, which is 5 meter per second square towards right, will be nothing but 40 minus n. So you can write the net force in direction of acceleration 40 minus n equals to mass into acceleration 5 into 5. So 40 minus n equals to 25, or you can get normal reaction equals to 15 Newton. Here you can see to find the normal between the bodies, you can either look at forces on 3 kg or the forces on 5 kg. But I know that you like looking at the forces on the 3 kg rather than 5 kg, right? How to solve the question if there are more than 2 blocks? What if there are 3 blocks? So let's see this example. Now we have got 3 blocks. One block of mass 5 kg, second block of mass 3 kg, third block of mass 2 kg. And on this whole system of 3 blocks, a force of 100 Newton acts from the left and a force of 50 Newton acts from the right. Question is, what will be the common acceleration of these 3 blocks? So you will say the common acceleration has to be the net force on the system upon the total mass of the system. We can assume these blocks to be welded, to be joined together. So the total mass of system will become 5 kg plus 3 kg plus 2 kg, that is 10 kg. And the common acceleration will be equal to net force. The force of 100 is towards right, the force of 50 is towards left. Force is a vector quantity. So the net force on this whole system will be equal to 100 minus 50. So we can say the common acceleration has to be equals to the net force upon the total mass of system. That will be equals to 100 minus 50 upon total mass of system, which is 5 plus 3 plus 2. 100 minus 50, numerator becomes 50, denominator 5 plus 3 plus 2 becomes 10 kg. So you get the common acceleration to be 5 meter per second square towards right. Once you know that the common acceleration is 5 meter per second square towards right, they might ask you what is the normal reaction between 5 kg block and 3 kg block. We know that the 5 kg block will apply a normal reaction on 3 kg block towards right, pushing in nature, and the 3 kg block will apply a normal reaction on the 5 kg block towards left. Similarly, there will also be normal reaction between 3 kg block and 2 kg block. The 3 kg block will push the 2 kg block, let's say with a normal reaction N dash, and the 2 kg block will push the 3 kg block, let's say with the same magnitude of normal reaction N dash. The forces have to be equal and opposite as per Newton's third law. So now, normal reaction by 5 kg on 3 kg. To find the normal reaction by 5 kg or 3 kg, we can either look at the forces acting on the 5 kg, or we can look at the forces acting on the 3 kg 2 kg system. Let's do both the ways as of now as we are learning. So if we look at the forces acting on the 5 kg, assume that the normal reaction applied by 3 kg on 5 kg is N towards left. So you will get the forces acting on 5 kg to be 100 from left and N from right. Or you can think of the forces acting in horizontal direction on the 3 kg plus 2 kg system. On the 3 kg plus 2 kg system, there is a normal reaction because of the 5 kg, and there is an external force of 15 Newton. So you can write the equation, the net force in direction of acceleration equals to mass into acceleration. So for this first case, you will write the net force in the direction of acceleration towards right will be equal to 100 minus n. So you can write equation 100 minus n equals to mass into acceleration, that is 5 into 5. So the normal reaction has to be equal to, from here you can calculate 75. Or you can make the equation on the 3 kg 2 kg system. You will say the net force in direction of acceleration equals to mass into acceleration. The net force towards right will be n minus 50 equals to mass 3 plus 2 into 5. So you get n minus 50 equals to 3 plus 2 into 5. That becomes 5 into 5, that is 25. So solving from here, the first case, you will get the normal reaction to be equals to 75 Newton. Or solving from here, the second case, you will get normal reaction equals to 75 Newton. I know that you are smart enough that you won't find the same normal reaction twice, right? I know even this, that you like looking at the forces on the 5 kg more than on the 3 kg 2 kg system. But both the things help at different places. Now, what if we need to find the normal reaction between 3 kg and 2 kg? So let's find it out. Normal reaction between 3 kg and 2 kg. So as to find the normal reaction between 3 kg and 2 kg, either you can look at the 5 kg and 3 kg system, or you can look on the 2 kg mass. So visualize their free body diagram. On the 5 plus 3 kg system, this whole system, there is external force of 100 Newton from the left, and let's say a normal reaction by 2 kg block N dash from the right. Or you can look on the 2 kg block. On the 2 kg block, there is external force of 50 Newton from the right and a normal reaction, say N dash, from the left. Either you can make the force equation on the 5 kg 3 kg system, or you can make the force equation on the 2 kg mass. We can use the net force in direction of acceleration equals to mass into acceleration. In the first case, the net force in direction of acceleration is nothing but 100 minus n dash, and this 100 minus n dash, the net force in direction of acceleration equals to mass 5 plus 3 into acceleration 5. So that becomes 8 into 5. Or to find the normal reaction between 3 kg and 2 kg, you can look at the forces acting on the 2 kg. You will say the net force in direction of acceleration n dash minus 50 equals to mass into acceleration 2 into 5, that becomes 10. If you find n dash from here, you can see 100 minus n dash equals to 8 into 5, that is 40. So 100 minus n dash equals to 40. So you get n dash equals to 60 Newton. Or you will get the same result if you look on the 2 kg block. You will say that n dash minus 50 equals to 2 into 5, that is 10. So n dash has to be equals to 60 Newton. Both are same result. So I know that here you might have liked writing the force equation on 2 kg move. But you should understand that we can even write the force equation on 5 kg, 3 kg system. What if rather than having blocks, we have string? So let's see that case. Now let's say we have got two blocks, one of mass 6 kg, one of mass 4 kg, and we are pulling the whole system with a force of 100 Newton. Because of string constraint, as both the blocks are connected by an inextensible string, both the blocks are bound to have the same acceleration. If both the blocks are bound to have the same acceleration and there is going to be no relative motion between the blocks, the separation between them is going to be constant, I can treat the whole system as a rigid body. And I will say the net external force on this whole system is 100 Newton. The mass of this whole system is 6 kg plus 4 kg, that is 10 kg. So the common acceleration of this system has to be the net external force 100 upon the total mass of system, that is 6 kg plus 4 kg. So we get from here the common acceleration will be equal to net force upon total mass, that will be 100 by 6 plus 4, 10. So that comes out to be 10 meter per second square. Once we have found what is the common acceleration, they might even ask me, tell what is the tension in this string. So as to find the tension in the string, either you can look at the forces on the 6 kg block or you can look at the forces on the 4 kg block. We will right now do it for both of them, but later I will make equation on any one of them. And you should try to make the equation on other one to check whether you get the same answer or not. Okay, so now let's look at the forces on the 6 kg block and the 4 kg block. On the 6 kg block, there is only one force in horizontal direction that can provide this horizontal acceleration of 10 meter per second square. And that force is the force of tension by the string. On the 4 kg block, there is an external force of 100 Newton towards right. And let's say a string force T towards left. We will again make the equation the net force in direction of acceleration equals to mass into acceleration. So for the 6 kg block, I will say that T equals to 6 into 10. And for this 4 kg block, I will say the net force in direction of acceleration, that is towards right, 100 minus T equals to 4 into 10. So from here we directly get T equals to 60 Newton, and from here also we get the same result, 100 minus T equals to 40. So T has to be 100 minus 40, that is 60 Newton. So we get tension equals to 60 Newton, tension equals to 60 Newton. Let's practice one more question. What if there are 3 blocks rather than 2 blocks? So now let's see this case. Here we have got 3 blocks of mass 5 kg, 3 kg, 2 kg. A force of 100 Newton is applied to the right, a force of 50 Newton is applied to the left, and they are asking me to find the tension in both the strings. What to do? I know that in this case, the whole system will have a common acceleration in the direction of net force. So I can treat the whole 5 kg plus 3 kg plus 2 kg system as a rigid body. The common acceleration will be equal to the net force on the system, 100 minus 50, upon the total mass of system, which is 5 kg plus 3 kg plus 2 kg. So the common acceleration comes out to be net force upon total mass. The net force is 50 Newton, 100 minus 50, upon the total mass, which is 5 plus 3 plus 2, which is 10 kg. So we will get the common acceleration to be 5 meter per second square. Do it, 50 by 10, 5 meter per second square towards right. Once you know what is the common acceleration, and we need to find tension in both the string. Let's say the tension in the string on the left is T1 and the tension in the string on the right is T2. The force of tension is along the length of string and is pulling in nature. So this first string, which is on the left, will try to pull the 5 kg block towards itself, as well as will try to pull the 3 kg block towards itself. Similarly, the tension present in the second string is pulling in nature. It will try to pull the 3 kg block towards itself, and it will also try to pull the 2 kg block towards itself. That's why the arrow marks are made. To find the tension, either we can look on the 5 kg block or we can look on the 2 kg block. So first of all, let's find out the tension T1. To find the tension T1, we can look at the 5 kg block or at the combined system of 3 kg and 2 kg block. Here I will choose to look on the 5 kg block. So on the 5 kg block, there is a force of T1 towards right, external force of 50 towards left. The net force in direction of acceleration equals to mass into acceleration. To find the tension T2, we should look at the 2 kg block. On the 2 kg block, there is an external force of 100 Newton towards right. There is a tension T2 towards left. We can again say the net force in direction of acceleration equals to mass into acceleration. So, for the first block, we will make equation T1 minus 50 equals to 5 into 5. And for second block, we will make equation the net force in direction of acceleration 100 minus T2 equals to mass 2 into acceleration 5. So 100 minus T2 equals to 2 into 5. Solving from here, we get T1 equals to 50 plus 25, 50 plus 25 equals to 75 Newton. And looking on the second block, 100 minus T2 equals to 2 into 5. So T2 has to be also equal to, T2 will be equal to 90 Newton. Okay, simple. Now let's do one more problem. A train having 10 bogies is accelerating with an acceleration of 2 meter per second square. So the train has 10 bogies and it is accelerating with an acceleration of 2 meter per second square. If the mass of each bogie is 5000 kg, determine the force by fifth bogie on the fourth bogie from the end. So what will be the force applied by the fifth bogie on the fourth bogie from the end? So first of all, visualize the train. The train has got 10 bogies, but here we are not at all drawing 10 bogies. They are asking me what is the force applied by fifth bogie on the fourth bogie from the end. So the force applied by fifth bogie on the fourth bogie will be responsible for accelerating the first bogie from the end, the second bogie from the end, the third bogie from the end, and the fourth bogie from the end. So the force applied by fifth bogie from the end will be responsible for the acceleration of this 4m mass. So how much force the fifth bogie from the end must be applying on the fourth bogie from the end? So this is a simple question. You will say the net external force in the direction of acceleration equals to mass into acceleration. If I take the mass of each bogie to be m, we have got 4 bogies here. So the overall mass becomes 4m. And if all these bogies move with an acceleration a, then the force has to be nothing but the combined mass of system into acceleration. So we get from here, the force by fifth bogie from the end on the fourth bogie provides the acceleration to the 4 bogies. So we can say the tension force has to be equals to 4m, the mass combined of the 4 bogies into acceleration a. Substitute the value of mass. The mass is 5000 kg. And the acceleration is 2 meter per second square. We get that the tension equals to 4 into 5000 into 2. 5000 into 2 becomes 10,000 and 10,000 into 4 becomes 40,000. So that force of tension has to be 40,000 Newton. 40,000 Newton can also be written as 40 kilonewton. So this will be the force. So now let's talk about motion on block on a fixed incline. So let's say we have a fixed incline, definitely smooth, we are doing friction later. So we have a block on this fixed incline which is frictionless, and we have kept a block on the top and released it. What will be the acceleration of this block? How much time this block will take to reach the base? What will be the velocity of block on reaching the base? What will be the force of normal by the incline on the block? We are going to discuss all these things. So motion of block on a fixed incline. First of all, this is a smooth incline, so there is no friction anywhere. Let's look at the forces acting on the block placed on this incline. So if this block slides down with an acceleration a, we need to visualize first the forces acting on this block. We can say because of the inclined surface, there will be a force of normal, yes sir. And because of force of gravity, there will be a force downward, mg, yes. Under the influence of these two forces, the force of normal along the normal and the force of gravity downward, the block will slide down along the surface of incline. We can assume any type of orthogonal coordinate system. So here I am choosing x-axis along the incline and y-axis perpendicular to the incline. The force of normal is already along the direction perpendicular to incline. So the force of normal is already in the y direction. But our force of mg now is downward. So we need to break down this force of gravity mg down into components along the x and perpendicular to x, that is y. If this angle is theta, this angle right here, kids, will be 90 minus theta. So the component of force of gravity along the x, that is along the incline, will be mg cos 90 minus theta. And mg cos 90 minus theta is nothing but mg sin theta. Similarly, the component of force of gravity perpendicular to incline will be equals to mg sin 90 minus theta, and sine of 90 minus theta can be written as cos theta. So that will be mg cos theta. So we can break down the force of gravity into components along the incline and perpendicular to incline. And these forces comes out to be mg sin theta and mg cos theta. Physics gives you freedom to choose your own axis. I have here chosen axis along the incline and perpendicular to incline. Now since I know that the block accelerates along the incline, so the block accelerates only in the direction I have chosen as x. The block does not accelerate in the direction I have chosen as y. So we can say as the acceleration in y direction is 0, as the block does not accelerate in the direction I have chosen as y, as the acceleration in y direction is 0, the net force in y direction should be 0. Which are the forces acting in the y direction? The normal and the component of force of gravity. If the net force in the y direction has to be 0, as there is no acceleration in the y direction, we can say the force of normal will be equals to mg cos theta. So normal reaction has to be equals to mg cos theta. Now let's think of the x direction. We know that in the x direction the block accelerates here. The net force acting in the direction of acceleration should be equal to mass into acceleration. What is the force acting along the x direction? Sir, the component of force of gravity. Which one? Sir, mg sin theta. So because of this component of force of gravity mg sin theta, the block will slide down. And how much will be the acceleration? Sir, simply the net force in direction of acceleration equals to mass into acceleration. So we can say there is only one force which is the component of force of gravity along the x direction, which is mg sin theta. So net force in direction of acceleration mg sin theta equals to mass into acceleration. So the acceleration comes out to be g sin theta, and I know that you already know this. So the acceleration of this block down the incline will be g sin theta. Now let's say this incline has a height h, the inclination is theta, and this inclined surface length is L. First thing first, what will be the relationship between theta, the height h, and the length of the inclined surface L? So you will say, sir, sine theta equals to h by L. Or you can say this inclined surface L equals to h by sine theta. Now, since we know that this inclined surface length will be equals to h by sine theta, we need to find more things here. We have found what is the normal reaction mg cos theta. We have found what is the acceleration. We need to find how long it will take for the block, if released from top, to slide to the bottom. So using the second equation of motion, we can say that if the block starts with 0 initial velocity, if the block starts from rest and starts sliding down with an acceleration g sin theta, from the second equation of motion, we can say the displacement L equals to half times the acceleration down the incline into t square. So from here, we can say L equals to half times the acceleration is g sin theta into t square. Or we can say the time taken to slide down has to be nothing but under root of 2L by g sin theta. Just rearrange these terms, you will get the time has to be under root of 2L by g sin theta. But many a time in the question, you have to report the answer in terms of h and theta and not use L. So in place of the length of the inclined surface, you can substitute h by sine theta. So what we get is the time is under root of 2 by g. In place of L beta, substitute h by sine theta, and there is one more sine theta in the denominator. In the denominator, now we have got two sine thetas. So in denominator, we get sine square theta. So that can be pulled out of the under root. So we can write the time taken has to be 1 by sine theta into under root of 2h by g. So this will be the time taken by the block to slide. What will be the speed of the block on reaching the base? If the block has an acceleration a and it travels a length L, from the third equation of motion, let's say the final speed is v, we can say the final velocity square minus the initial velocity square equals to 2 times acceleration into displacement. Now we get V equals to under root of 2AL. In place of A, you can write G sine theta. In place of L, you can write H by sine theta. So we can say speed on reaching the base has to be equals to V equals to under root of 2 into acceleration G sine theta into the length, which is H by sine theta. You can see the term of sine theta get cancelled. So the speed at the base comes out to be root 2 GH. Now this question get asked. If a block is released on the top of a smooth incline, and if a block is dropped from the same height, in which case the block will reach the ground level first. So you can see that here the time taken to fall will be under root of 2h by g. We have learned it already. Here the time taken to slide down is 1 by sine theta times under root of 2h by g. As we have got an extra term of sine theta in the denominator, which is a number less than 1, in this case it will take more time to slide down. The another question that get asked, which block will reach the ground level with a higher speed? From energy conservation, since both the blocks lose same amount of gravitational potential energy mgh on reaching the base, both will gain the same amount of kinetic energy on reaching the base. That's why on reaching the base, the speed of both of them has to be root 2 gh. So this is something that you should know. Okay. Moving on. So now we will talk about constraints. And the first type of constraint we are going to discuss is the constraint of rigid body. What is a rigid body? A rigid body is rigid. So a rigid body can't be compressed. A rigid body can't be elongated. A rigid body is rigid. Now let's say we have this rigid body and visualize 2 points on the rigid body, point 1 and point 2. Since it can't be compressed or it can't be elongated, the separation between these 2 points R has to be constant. So sir, can we say, if you think of any randomly shaped rigid body and if you visualize any 2 random points on this rigid body, say A and B, then the separation between these 2 points A and B should remain constant. Now let me ask you a very simple question. Let's say there are 2 friends walking on street. The friend behind walks with speed of 4 meter per second. The friend in front walks with speed of v meter per second. Question is, what has to be the value of v so that the separation between them remains constant? We know that if v will be greater than 4 meter per second, then the friend in front will move faster and the separation between them will increase. If v will be less than 4 meter per second, then the friend in front moves slower and the friend behind will catch up and the separation between them will decrease. For the separation between these 2 friends to be constant, the speed of the friend in front should also be 4 meter per second. So we learned a concept here, and the concept is that if we want the separation between these 2 guys to be constant, then they should have the same velocity along the line joining them. Once more repeating, if we want the separation between these 2 guys to be constant, then they should have the same velocity along the line joining them. And this is exactly the statement of constraint of rigid body. So let's see. If we have 2 points on a rigid body, then their velocity along the line joining them should be equal. If we have 2 points on a rigid body, then their velocities along the line joining them should be equal. Let's visualize this case where the point 1 has a velocity u at an angle theta with the line joining point 1 and point 2. And the second particle 2, has a velocity v at an angle phi with the line joining particle 1 and particle 2. The rigid body constraint says that both the particles should have the same velocity along the line joining them. Only then the separation between them won't increase or won't decrease. So if both the particles should have same velocity along the line joining them, we can break down these velocity into components. The component of velocity of first particle along the line joining them will be u cos theta, and the component perpendicular to the line joining them will be u sin theta. Similarly, the component of velocity of particle 2 along the line joining them will be v cos phi, and the component of velocity perpendicular to the line joining them will be v sin phi. If we want the separation between particle 1 and particle 2 to be constant, then their velocity along the line joining them should be equal. So u cos theta has to be equals to v cos phi, and this is the constraint of rigid body. So we can say if these 2 points are on a rigid body, then their velocities along the line joining them should be same. Hence we can say that u cos theta, the component of the velocity of particle 1 along the line joining them, should be equal to the component of the velocity of particle 2 along the line joining them, that is v cos phi. So u cos theta has to be equals to v cos phi. Let's practice a question based on this. Determine the speed of NA of the rod at this instant. So there is a rod, and we can see the terminal B of the rod moves along the floor with a speed u. The inclination of the rod is theta, and they are asking me what is the velocity of the end A of the rod. We know that the end A might have a velocity downward, and we need to find this velocity's magnitude. We have learned from the rigid body constraint that both the points A and B should have the same velocity along the line joining them. And once you know this statement, this question is super duper simple. So visualize a line joining A and B, find the component of velocity of both A and B along this line and equate it. So let's do it. Assuming that the end A has velocity v downward. So the end A has a velocity v downward. If this angle is theta, this other angle has to be equal to 90 minus theta, right? Now we need to find the component of velocity of A and B along the line joining them, and we are going to equate it. The component of the velocity of A is v downward. The angle made by velocity of A with the line joining A and B is 90 minus theta. So the component of velocity of A along the line joining them will be v cos 90 minus theta, and v cos 90 minus theta can be written as v sin theta. Similarly, the velocity of B makes an angle theta with the line joining A and B. So the component of velocity of B along the line joining them will be equals to u cos theta. So we just need to equate these two velocities. As both the points are on rigid body, they must have same velocity along the line joining them. Otherwise the separation between them might increase or might decrease. So as both the end A and B will have same velocity along the line joining them, we can say that the component of velocity of A along the line joining them, v cos 90 minus theta, equals to the component of velocity of B along the line joining them, that will be u cos theta. In place of cos 90 minus theta, we can write sin theta. So we get v sin theta equals to u cos theta. V sin theta equals to u cos theta. And once you know that v sin theta equals to u cos theta, you can write v as u cos theta by sin theta. You can write this cos theta by sin theta as cot theta. So you get the velocity of terminal A to be equal to u cot theta. Easy. Let's see the next one. So now let's talk about the second type of constraint, the constraint of constant contact. Visualize that you have a fixed surface, and on the fixed surface you have a block. If you want the block to be always in contact with the surface, how can the block move? So the block can move in the plane of the surface, but the block can't move perpendicular to the plane of the surface. If the block tries to move perpendicular to the plane of the surface, it will lose contact with the surface. So the block can only move in the plane of the surface. So can we say that the block should have zero velocity along the normal? If the block has any velocity along the normal, then it will lose contact. Either it will break the surface or it will lose contact. So the constraint of constant contact tells us if there is a fixed surface and the block is always in contact with the surface as it moves, its velocity along the normal should be zero. So if the block is always in contact with the fixed surface, its velocity should be only along the surface. Its velocity along the normal should be zero. The velocity perpendicular to the surface should be zero. The block shouldn't have any velocity perpendicular to the surface. For a fixed surface, velocity in normal direction should be zero. So if a block moves in constant contact on a fixed surface, then the velocity in the normal direction should be 0. This is the concept. But this particular concept becomes tough when the surface is not fixed. If the surface is moving, then what statement should we use for constant contact? For a fixed surface, it is easy to understand that if the block shouldn't lose the contact with the fixed surface, then it shouldn't have any velocity along the normal direction. It should have velocity only along the surface, right? But what if the second surface is not fixed, as we will see in some of the example following? Then we have learned a beautiful chapter called relative motion. If we look at the motion of this block in the frame of the surface, if we look at the motion of the block in the frame of the surface, when we look in the frame of the surface says, I am fixed, I am static, I am not moving. This block is moving on me. So in the frame of the surface, the velocity of the block in the normal direction should be 0. If in the frame of the surface, the velocity of the block in the normal direction should be 0, it means that both the surfaces should have same velocity along the normal. So let's see. Hence, in the frame of the surface, the velocity of the block should be 0 in normal direction. If in the frame of the surface, the block should not have any velocity in the normal direction, it means that in the normal direction, both the surface and the block should have the same velocity. Then only the relative velocity along the normal will be 0. So let's say we have got this random surface, and this random surface is moving, and this block is also moving. So their velocity components along the normal should be same. Only then, with respect to surface, the block won't have any velocity along the normal, and their relative velocity along the normal will be 0. So hence both the block and the surface should have the same velocity in the normal direction. Both the block and the surface should have the same velocity in the normal direction. So the velocity and acceleration along the normal should be same. So you explain everything for velocity. Now you suddenly incorporated acceleration as well. Beta, if I tell you along the normal both should have same velocity, then I differentiate it, then along the normal both should also have the same acceleration. No? So we say if there is a constant contact between a block and a surface, then both of them should have the same velocity along the normal, and both of them should have the same acceleration along the normal. To understand it better, let's do some examples based on this. The first example, if the intruder moves down with a constant speed v, determine the speed of the wedge. So in this case, there is an intruder going down with a constant speed v. The inclination of the wedge is theta. You need to find the speed of the wedge. So what has to be the relationship between the speed of the wedge and the speed of the intruder, so that the intruder always maintains contact with the surface of the wedge? We have just learned that if two bodies are in constant contact, then they should have the same velocity and the same acceleration along their normal. For this surface, if we draw the tangent at the point of contact, the normal has to be perpendicular to it. So the normal will be in this direction. Find the velocity of both wedge and the intruder along the normal and equate. It is that easy. So assume that the wedge moves with a speed u towards left. Assume that the wedge moves with a speed u towards left. If the wedge is always in contact with the intruder, then both must have the same velocity along the normal. So just find the component of velocity of wedge along the normal, the component of velocity of intruder along the normal, and equate it. How to find it? See, it is simple than it appears. This angle is theta. Yes, sir. So what will be this angle? This will be 90 minus theta. Right? So what will be this angle? Sir, this is normal. And this is the surface. Yes. So this whole angle has to be 90. So if this angle is 90 minus theta, then this remaining angle has to be theta. Okay. Now the speed of the wedge is u towards left. The angle made by the velocity of the wedge with the normal will be 90 minus theta. So the component of the velocity of the wedge along the normal will be u cos 90 minus theta. Well begun, half done. Now we need to find the component of the velocity of intruder along the normal. That we already know. When the force of gravity is downward mg, the component comes out to be mg cos theta. So here the velocity of intruder is downward v, the component will come out to be v cos theta. But let's find it out. We can say the intruder has downward velocity v. This angle is theta, so this angle is 90 minus theta. So the component of velocity of intruder along the normal will be this component, and that will be v sine 90 minus theta. And v sine 90 minus theta can be written as v cos theta. Just like the component of mg along the normal comes out to be mg cos theta. So equating the velocities along the normal, the velocity of intruder along the normal will be v sine 90 minus theta, and this has to be equal to the velocity of wedge along the normal, that will be equals to u sine theta. Sine of 90 minus theta can be written as cos theta, so you can simply write v cos theta equals to u sine theta. So the velocity of wedge u has to be equal to v cos theta by sine theta, which becomes v cot theta. These type of questions look super tough, but they are easy once you have understood the statement of the constraint. Let's practice one more question before we move on to the next type of constraint, which is a string constraint. So the next example. If the acceleration of wedge is such that the block falls freely under gravity, maintaining the contact, determine the acceleration of wedge. So if the acceleration of wedge is such that the block falls freely under gravity, maintaining the contact, determine the acceleration of wedge. Beta, if the block falls freely under gravity, then what will be the acceleration of the block? So that if the block falls freely under gravity, then the acceleration of the block has to be g downward. But the block constantly maintains contact with the wedge. So if they constantly maintain the contact, then the component of their acceleration along the normal should be same. So we can say if the block falls freely, its acceleration is g downward. So the acceleration of block is g downward, acceleration of wedge is a. What will be the component of this acceleration of block g downwards along the normal? So it's easy. This angle is theta. So this angle has to be 90 minus theta. So this angle right here, bacho, has to be theta. The component of acceleration of block along the normal will be g cos theta. What will be the component of acceleration of wedge along the normal? So extend this line, bacho. If this angle is theta, this angle will also be theta. So the component of acceleration of wedge along the normal, this direction will be a sine theta. So equating both the accelerations along the normal, for constant contact equating the accelerations along the normal, we say that a sine theta, the component of acceleration of wedge along the normal, equals to the component of the acceleration of block along the normal. So we get a sine theta equals to g cos theta, or the acceleration has to be g cos theta by sine theta, that becomes g cot theta. So let's move on to the part you were waiting for, the string constraint. The length of an inextensible string is constant, and this is the only thing we use in string constraint. The length of an inextensible string is constant. It neither increases nor decreases. Let's start with a very simple case. Let's say we have got these two blocks and the string is passing over a pulley. We need to find the relationship between the speed of these two blocks given that the string is inextensible. The block on the left has a speed u upwards and the block on the right has a speed v downward. What is the relation between these two speeds? I know that you already know that u has to be equal to v. But here I am explaining this so that you understand how to apply string constraints. So listen very carefully. We can say that if I assume the length from the top of the left block to the place where the string touches the left hand side of pulley as L1, and if I assume the length of the string where it touches the pulley on the right hand side to the top of the block on the right and call it L2, we can say that the sum of these two lengths has to be constant as the length of the string is constant. So L1 plus L2 has to be constant. I'm going to say something now which is really important. While applying string constraint, never ever look at the string. While applying string constraint, never ever look at the string. When I said the length L1, what is L1? The L1 is the length of string. Which string? The string on the left. What? The place where the string touches the block to the place where the string touches the pulley. That is L1. Now, if you look at these two terminals of this particular length L1, where do you define the upper terminal? Sir, where it touches the pulley. Is the pulley moving? No. Since the pulley is not moving, the velocity of this terminal is 0. And since the block is going up with a speed u, the terminal of the string of length L1 is going up with a speed u. Now I ask you, what is L2? So L2 is the length of what? String. From where to where? Where it touches the pulley to where it touches the block. Is this terminal which is in contact with pulley, is it moving? No, because the pulley is fixed. But sir, the string will move now. Do not look at string. Do not look at string. Where have you defined the length L2 to be from to from? Where it touches the pulley to where it touches the block, right? Is the pulley moving? No. So is this point moving? No. This point on the block is coming down with a speed v. Now let's go further. If we differentiate the equation both the side, we can say that the rate of change of length 1 with respect to time plus the rate of change of length 2 with respect to time equals to the rate of change of constant with respect to time, and constant doesn't change with time. So the rate of change of constant with respect to time has to be 0. So we say dl1 by dt plus dl2 by dt equals to 0. What is L1? Sir, this length from the pulley till the block. Is the upper terminal moving? No. Is the lower terminal moving? Yes. With how much speed? U upwards, because it is connected to the block and the block is going up with a speed u. So I ask you, what is dl1 by dt? Sir, the rate of change of length 1 with respect to time. The upper point is fixed and the lower point moves up with a speed u. So the length 1 will increase or decrease? Sir, it will decrease. So what should you call the rate of change of length 1 with respect to time? We say that the rate of change of length 1 with respect to time is minus u. So dl1 by dt will be minus u. What about dl2 by dt? So dl2 by dt represents the rate of change of length 2 with respect to time. This terminal of length 2 which is on the pulley is not moving, as the pulley itself is not moving. So this is fixed. But the second terminal which is connected to block will move as the block is moving down with a speed v. What does dl2 by dt represent? dl2 by dt represent the rate of change of length 2 with respect to time. The upper terminal is fixed and the lower terminal goes down with a speed v. So the length 2 is increasing at what rate? At a rate v. So we say that dl2 by dt has to be plus v. So from here we get minus u, which is dl1 by dt, as the length 1 is decreasing. It is not at all increasing. That's why the decrease in length with time, minus u, and the length 2 is increasing. That's why plus v. So minus u plus v equals to 0. So from here we get that u equals to v. Now you will be like, sir, I already knew this. Why you wasted up so much of time to learn the concept which will be used in the later problems? Now once we have got v equals to u, differentiating both the side, we will say that dv by dt equals to du by dt. What is dv by dt? The rate of change of velocity with respect to time, which will be the acceleration of second block. And what will be du by dt? The rate of change of velocity of the first block with respect to time, that will be the acceleration of first block. So on differentiating, we can even say that a1 equals to a2. The acceleration of both the blocks have to be equal, right? Now let's see a little more advanced example, then we will move to quite good example. The second example. Now rather than having one pulley, we have got two pulleys, and we have got two blocks, a block on the left going up with speed u and a block on the right coming down with speed v. Our mission is to find the relationship between the speed u and the speed v. The number one rule of string constraint: never ever look at string. So we have divided this string into three parts: the length L1, the length L2, the length L3. We can say that L1 plus L2 plus L3 has to be constant. So dL1 by dt plus dL2 by dt plus dL3 by dt has to be equals to differentiation of constant, which is 0. Now, what is dL1 by dt? Look at the length one. Just focus on the length one. It is defined from the place where it touches the ceiling. Is the ceiling moving? No. So the velocity of this terminal is 0. Is the second terminal of length 1 moving? That the block goes up with a speed u. If this string does not get loose, this means that the center of pulley will also go up with a speed u. If the center of the pulley goes up with a speed u, then its left end as well as right end, both of them will go up with the same speed u. Visualize a disk whose center goes up with a speed u, so the left end as well as right end both will go up with the same speed u. So our first mission is to write dL1 by dt. The upper terminal of length 1 is fixed. The lower terminal will have the same velocity as the center of pulley, and the center of pulley will have the same velocity as the block. Why? Because this string shouldn't get slacked. So you will say the center of pulley will have a velocity upwards u. So this left end of the pulley where the length 1 has been used to define, it will also have upward velocity. So dL1 by dt should be written as minus u. Why minus u? Because this length is decreasing. So dL1 by dt bachon is minus u. Now how to write dL2 by dt? Length 2 is defined from where the second string touches the upper pulley to where it touches the lower pulley. Is the upper pulley moving? No. Why? Because it is fixed. Because it is straight connected to the ceiling. It can't move. This end is fixed. So it is not at all going upward or downward. But this end is going up with a speed u. So what will you write dL2 by dt? So the upper end is fixed for this string of length L2. The upper end is fixed, and the lower end, which is on this pulley, which is connected to block, since the block goes up with speed u, the center of this pulley goes up with speed u, so the right end goes up with speed u. So dL2 by dt will also be minus u. So dL1 by dt will be minus u. dL2 by dt will be minus u. Now let's talk about dL3 by dt. Length 3 is defined where the string touches the pulley to where the string touches the block. Is this end moving? No, because this pulley is static. It is not moving. Is this end moving? Yes, it goes down with a speed v. So we can say that the length 3 is increasing. So dL3 by dt has to be positive. It has to be equal to v, upper end fixed, lower end going down with speed v. So dL3 by dt has to be v. So what we get here is dL1 by dt plus dL2 by dt plus dL3 by dt has to be 0. So minus u plus v has to be equals to 0, or bachon, v has to be equals to 2u. Let's see the next example. Keep focusing, it's not tough. Also, if we need to find the acceleration, differentiating both the sides, we will say dv by dt equals to 2 times of du by dt. So we can say that the acceleration of this block A2 is double the acceleration of the block on the left. So A2 equals to 2 times of A1. Let's see the next example. Now we have got even more pulley and even more block. Now we have got 3 blocks and we have got 4 pulleys. What to do? It's very easy. Just keep on applying the string constraint, and when you apply string constraint, don't look at the string. So here we can say that L1 plus L2 plus L3 plus L4 plus L5 equals to constant. Yes, sir. Now differentiating them, we can say that dL1 by dt plus dL2 by dt plus dL3 by dt plus dL4 by dt plus dL5 by dt equals to 0. Now let's start focusing on each length. The length L1 from ceiling, this is not moving. Now this end is connected to pulley, and the pulley is connected to block, and the block is going down with the speed u. If the block is going down with a speed u, then for this string not to get slacked, the center of the pulley should also go down with speed u. If the center of this pulley goes down with a speed u, then its left end as well as the right end will go down with the speed u. So what will you write dL1 by dt? The upper end is fixed and the lower end goes down with a speed u. It is trying to increase the length. So you will write dL1 by dt as plus u. dL1 by dt will be plus u. What about dL2 by dt? Sir, this upper end is fixed. How do you know? Because sir, it is connected to a pulley and that pulley is fixed to the ceiling. So since this second pulley can't move, its left end can't move, so this end is fixed. Okay. What about the other end? Since the block goes down with the speed u, the center of the pulley goes down with the speed u, so the right end of the pulley will go down with the speed u. So dl2 by dt, the upper end fixed, the lower end going down with speed u, so dl2 by dt will also be plus u. Now let's talk about dl3 by dt. Length 3 from here pulley to here pulley. The upper end of pulley is fixed, no problem. Let's talk about the lower end. Is this third pulley fixed? No. We can see here, if the block goes up with the speed v, then for this string to not get slack, the center of the pulley should also go up with speed v. When the center of the pulley goes up with speed v, the left end as well as the right end goes up with speed v. So dl3 by dt should be minus v. Sir, why do you place minus? How do you know? The upper end is fixed, the lower end goes up with the speed v, so dl3 by dt should be minus v as the length is decreasing. Now let's talk about length 4. Again, since this pulley is fixed, the left end is fixed, so the upper end of the length 4 is fixed. Now let's talk about the lower end. Since the block goes up with the speed v, the center of the pulley will go up with speed v, so its right end will also go up with speed v. So dl4 by dt will be written as minus v as the length is decreasing. Now about the length, last length, which is L5, the upper end of this pulley is fixed and the lower end is connected to the block which goes down with a speed W. So length 5 is increasing. So you will say that dl5 by dt is plus W. So on substituting the data, we get dl1 by dt plus u, dl2 by dt plus u, dl3 by dt minus v, dl4 by dt minus v, dl5 by dt plus W. So plus u minus v plus w has to be equal to 0. So what we get from here is 2u plus w equals to 2v. So this is the relationship between the velocities. If you need to find the relationship between the accelerations, just differentiate out each term. Let's practice more question. Now here in this case, you need to find the relationship between the velocity u and v. You need to find the relationship between the velocity of both the blocks. But here is a problem. Here we do not have one string. We have got two strings. So we have got this first string and this second string. So in this case, we will have to apply the string constraint twice. But before we do, let's assume the length to be L1, L2, L3, L4. And let's assume this pulley has some velocity, because I don't think that this pulley will be static, because as this block moves down, this pulley must move towards right. So let's say this pulley has some velocity W. Now let's start to apply string constraint one by one on both the string. So first on this string where I have assumed the length L1 and L2. So we can say that L1 plus L2 has to be constant and dl1 by dt plus dl2 by dt has to be 0. Now, how to write dl1 by dt? This end of the string where we have defined the length L1 is connected to wall. Yes, so this is fixed. The second end is on the pulley. This pulley has got its center moving with a speed W. So the upper end of the pulley will also be moving with speed W, while the lower end will also be moving with speed W. So what you will write dl1 by dt? Sir, easy. The left end is fixed and the right end is moving with speed W. So dl1 by dt has to be plus W. Okay. Now comes the catch. How will you write dl2 by dt? Sir, when we look at the length 2, the right end is where we have the pulley and the left end is on the block. If we just think of this length 2, the right end is on the pulley and the left end is on the block. This end on the pulley will move with the same speed as the center of pulley. So it will move with the speed W. This left end, which is on the block, will move with the speed U. We can see that the speed W is trying to increase the length 2, while the speed U is trying to decrease the length 2. Once more, the speed W is trying to increase the length 2, while the speed U is trying to decrease the length 2. So how will you write dl2 by dt? So we will say The speed w is trying to increase the length, the speed u is trying to decrease the length. dl2 by dt will be nothing but w minus u. So dl1 by dt will be plus w, dl2 by dt will be w minus u, and the sum has to be equals to 0. So from here we get the relationship that 2w equals to u. Now, how to find relationship between v and u? So we will apply now string constraint on the second string, this string. So we will say L3 plus L4 has to be constant. So dl3 by dt plus dl4 by dt has to be equals to 0. Now how will you write dl3 by dt? The length 3 is defined from the center of this first pulley to the top of the second pulley. As the second pulley is fixed, this terminal won't move. But this terminal which is on the pulley will move with a speed w. So we will write dl3 by dt equals to minus w. This end is fixed, this end moves with a speed w, so dl3 by dt will be minus w. What about dl4 by dt? This end is fixed, this end goes down with a speed v, so dl4 by dt will be plus v. So we will write dl3 by dt as minus w, dl4 by dt as plus v, so minus w plus v equals to 0, or we can say w equals to v. Our mission was to find relationship between u and v. We just incorporated w to create a relationship between the u and v using both the string constraints. Now, since we know that v equals to w and 2w equals to u, in place of w in the first equation you can substitute v, so we will get the relationship as u equals to 2v. Take w from here and substitute it in first equation, you will get u equals to 2v. It looks tough, but it's not that tough. Try it out once more. Let's see another example which is exactly brother of this but look a little more complex. So now in this case you have to find the relationship between u and v. Actually this is the exact same question as what we have just done. It's just that I have tilted the horizontal part and moved it on an incline. It's the same question. Okay, so before we solve again, here we have got two strings. So we will have to apply the string constraint twice. Now assume the length to be L1, L2, L3, L4, and assume that this pulley also have some velocity, let's say W. After assuming, we get a diagram like this. Now first apply a string constraint on the first string. So you will say that L1 plus L2 equals to constant, so dl1 by dt plus dl2 by dt equals to shunya, right? Now what will you write dl1 by dt? Sir, L1 is from here till the top of the pulley, yes. This end is fixed, not at all moving, but the top of the pulley is going with the pulley. We have assumed that the pulley goes with a speed w, so its top will also go with a speed w, so dl1 by dt will be nothing but plus w. What about dl2 by dt? If you haven't understood last time, please focus this time. Length 2 is defined from block till pulley. In string constraint, never ever look at the string, okay? So if you think of the length 2, okay, so this is the string. As the center of the pulley goes with a speed w, the lower end will also move with the speed w, yes. So tell me, this speed w is trying to increase the length or decrease it? Sir, it is trying to increase the length. Now look at this second terminal. It goes up the incline with a speed u. This speed u is trying to decrease the length. So w is trying to increase the length, u is trying to decrease the length. What will you write? dl2 by dt. So sir, we will say that dl2 by dt is w minus u. W is trying to increase the length, which we take as positive. U is trying to decrease the length, which we take as negative. So we will write it as w minus u. So you get w plus w minus u equals to 0 or 2w equals to u. Now let's make a string constraint equation for the second string. So again you will say L3 plus L4 equals to constant, or dl3 by dt plus dl4 by dt equals to 0. What will be dl3 by dt? If we look at this string, this end is on the pulley and the pulley is fixed, so this end doesn't move at all. But this end, which is connected to the center of pulley, will go up the incline with a speed of w. So dl3 by dt is minus w. What will be dl4 by dt? Length 4 is defined from pulley till the block. The top of the pulley is fixed because this pulley is fixed, and this point goes down with a speed v, so dl4 by dt will be plus v. So you will write minus w plus v equals to 0. Again, the same relationship, that w equals to v. Our mission is to find the relationship between u and v. We know that 2w equals to u and w equals to v. Substituting the value of w, we get that v equals to u. No. It's written wrong. We get the exact same result as the last time. We get that u equals to 2v. Okay, let's see the next example. Now you have to tell what is the relationship between v and u. What is the relationship between v and u? Now students start thinking something else rather than applying the equation of constraint. So let's say we assume this length to be L1 and L2 or vice versa. And again applying the string constraint, we can say that L1 plus L2 has to be constant. Now this block has got a speed towards right u. When I say that while applying string constraint, never ever look at the string. Look at the terminals which have been used to define the length. So what is L1? The length 1 is the length from where the string touches the block to where the string touches the pulley. Does this point on the pulley where the string touches the pulley moves? No sir, the pulley is fixed, so this point doesn't move. What about this point? So this point actually now moves horizontally with a speed u. Okay. So because of this motion of the point, what is the rate of change of length 1 with respect to time? Sir, we can break down this velocity into two components. One along the length, second perpendicular to length. So when you break down this velocity into component, the component of this velocity along the length will be u cos theta, and the component of this velocity perpendicular to length will be u sin theta as shown. Now I ask you kids, what will be dl1 by dt? You will say, sir, see, this end which is on the pulley is fixed because the pulley is fixed. But this end has got two velocity, one along the length u cos theta and another perpendicular to length u sin theta. This component of velocity along the length u cos theta is trying to decrease the length. So dl1 by dt will be minus u cos theta. What about dl2 by dt? Sir, dl2 by dt is easy. Length 2 is defined from this pulley till this block. This pulley is fixed, so this terminal is fixed, and as the block goes down with speed v, dl2 by dt will be plus v. So we will write L1 plus L2 equals to constant, dl1 by dt plus dl2 by dt equals to 0. dl1 by dt will be minus u cos theta. Why minus? Because this u cos theta is trying to decrease the length. So minus u cos theta plus v has to be equals to 0, or v will be equals to u cos theta. Now you are finding it tough? We will do two more examples of the same type. Keep focusing. Now in this case, there is a rod, horizontal rod fixed. Over the rod we have a ring going horizontally with a speed u. We need to find the relationship between u and v. How to do? It's very easy. Assume the length to be L1, L2 and just focus on length L1, L2. Okay. You will say length 1 is from where the string touches the ring to where the string touches the pulley. Does the point on the pulley move? No. Why? Because the pulley is fixed. But this point has got horizontal velocity u. You can break down this velocity into two components. One along the string, that will be u cos theta, and one perpendicular string, that will be u sin theta. This u cos theta is responsible for decreasing the length L1. So when I write dl1 by dt, this end is fixed, on the pulley is fixed. But because of the component of the tip on the ring along the length of string, you will say that dl1 by dt will be minus u cos theta. Why minus? Because it is trying to decrease the length. And writing dl2 by dt is cakewalk, as the pulley is fixed, this terminal is fixed, and the block is going down with the speed v. So dl2 by dt is plus v. So you will again write the same old drama, L1 plus L2 equals to constant, dl1 by dt plus dl2 by dt equals to 0. You will write dl1 by dt as minus u cos theta, dl2 by dt as plus v, minus u cos theta plus v equals to 0. Hence you will say v equals to u cos theta. The last example on string constraint. Let's say we have this case, and this is a very standard case, and I know that all of you have seen this. Our mission is to find the relationship between u and v. So now you don't need to look on both the sides because it's a symmetric system. So just look at one side. So let's look at the right hand side. We will say, assuming this length to be L1 and this length to be L2, we can apply the string constraint. As this block has velocity upward v, for this small string to remain tight, this tip should also have a vertically upward velocity v. Right? So this tip should also have a vertically upward velocity v. Now what is length L1? Sir, the distance from this tip to this pulley. This pulley is fixed, so this top terminal is not at all moving, and this terminal goes up with a speed v. Now you can break down this velocity into component, one along the string, that will be v cos theta, another perpendicular to string, that will be v sin theta. So what will you write dl1 by dt? So sir, the component of velocity responsible for reducing L1 is v cos theta. So dl1 by dt will be minus v cos theta. And writing dl2 by dt is sir cakewalk. The pulley is fixed, so this terminal is fixed. And since the block goes down with the speed u, this terminal will go down with the speed u. So dl2 by dt will be plus u. So what we will write is L1 plus L2 equals to constant. dl1 by dt plus dl2 by dt equals to 0. dl1 by dt will be written as minus v cos theta. So we write minus v cos theta plus u equals to 0 and u equals to v cos theta. So now with this done, we will move on to the most important part of the session, that is equation along the string. So equation along the string. The name itself gives some hint what we are going to do now. We know that if we have got two blocks, let's say of mass m1, m2, and two forces are acting on it, f1 and f2. If it is told to us that f1 is greater than f2, we know that since the net force on this system is towards right, it will have an acceleration towards right. What will be the value of this acceleration? We will write the acceleration will be equal to net force upon total mass. So acceleration will be equals to f1 minus f2 upon total mass, m1 plus m2, and this is how we can find the acceleration. Now here, how dare we write the acceleration equals to net force upon total mass? Because we have assumed the whole system as a rigid body. The whole system as a body of mass m1 plus m2. Okay. But under which condition we can assume a body to be a rigid body? When there is no relative motion between the things, when they have the same acceleration, then we can assume it. Now, thinking of the case of pulley with masses. If I tell you that m2 is greater than m1, I know that you know that m2 will move down and m1 will move up. So m2 will have acceleration in downward direction while m1 will have acceleration in upward direction. I asked this question in class and majority of students give the wrong answer. Will the acceleration of both the blocks be same? And all of them say, yes sir, no. Acceleration is a vector quantity. This block, lighter one, will have upward acceleration while the heavier block will have downward acceleration. The acceleration have the same magnitude, but the acceleration is not at all same. While in the last horizontal case, both have the same acceleration. That's why we treated them as a rigid body. So there is a way to go around this problem. Here we choose a special type of axis, an axis along the string. So let's assume I took an axis, folded it and gave it the shape such that it fits exactly on the string. Hence the name equation along the string. Now if we think of a curved axis which fits perfectly on my string, and let's say on this axis we have defined two directions. I am calling it gamma axis, not using x, y and z. I am calling it gamma axis. Let's say this direction is plus gamma and this direction is minus gamma. Why do we choose an axis along the string? Because it makes something really good. This block M2 has got acceleration downwards. Yeah. Think using the axis. This block M2 has got acceleration towards positive gamma or negative gamma. It has got acceleration towards positive gamma. And now think of M1. This M1 has got acceleration towards positive gamma or towards negative gamma. it also have acceleration towards positive gamma. So if we think of an axis along the string, then now both the blocks have the same acceleration, same magnitude and same direction, and now we can apply the equation along the string. So we will say now this case is as good as open that axis up again, and now visualize that on this block of mass m2 there is a force of m2g towards the positive gamma, and on the m1 there is a force of m1g towards the negative gamma. So open it up, a force of m2g towards positive gamma, a force of m1g towards the negative gamma, and now this case is same as the original case. And we can simply say if m2 is greater than m1, then the acceleration will be nothing but m2g minus m1g upon m1 plus m2. Now let's practice out some question using the equation along the string. The first question: find the acceleration of blocks at the tension. So here we have got two blocks, one of mass 4 kg, one of mass 6 kg, and we have got these two strings. The tension in the string connecting the blocks is T1, and the tension in the string connecting the pulley to the ceiling is T2. First of all, using the equation along the string, let's say I choose this direction as positive gamma and this direction as negative gamma. We can write the acceleration to be the force towards positive gamma 60 minus the force towards negative gamma 40. So the net force towards positive gamma is 60 minus 40, and the overall mass of system is 6 plus 4, that is 10. So we can say that the acceleration has to be the net force towards positive gamma divided by the total mass of system. So 60 minus 40 by 10, that becomes 20 by 10, that is 2 meter per second square. Once we have found the acceleration of the block, this will have acceleration of 2 meter per second square upward, this will have acceleration of 2 meter per second square downward. To find the tension T1, we can make the force equation on any one of the block. Either we can make the force equation on the 4 kg block, or we can make the force equation on the 6 kg block. Let's say to find T1, think of forces on one of the block. Let's say we look at the forces on the 4 kg block. On the 4 kg block, there is an upward force of tension T1. There is a downward force of gravity mg, and the mass is 4. So the downward force of gravity will be 4 into 1040. And under the influence of these two forces, we have already found it goes up with an acceleration of 2 meter per second square. So the block goes up with an acceleration of 2 meter per second square. Just make the equation the net force in direction of acceleration equals to mass into acceleration. So T1 minus 40 equals to mass into acceleration. So T1 minus 40 equals to 4 into 2. So T1 has to be equals to 48. In the question, they have even asked us to find T2. To find T2, look at the forces on the pulley. To find T2, think of the forces on the pulley. Now, if the pulley is massless, and three forces are acting on it. On the left hand side, the force of tension T1. On the right hand side, the force of tension T1. And at the center, because of this third string, the force T2 up. If the pulley is in equilibrium, then the net force on the pulley has to be 0. If the net force on the pulley has to be 0, then the force in upward direction should be equal to the force in downward direction. Hence, you can say that T2 has to be equals to T1 plus T1. Hence, T2 has to be equals to 2T1. Since we have found that T1 is 48 Newton, we get that the tension T2 comes out to be 2 into 48, that is 96 Newton. So now, using the equation along the string, we have found acceleration of both the block as well as T1 and T2. This particular system which we have just learned is called Atwood machine. Now let's say an Atwood machine has got two masses m1 and m2, where m1 is greater than m2. What is the acceleration of both the blocks? So again, if we think of the gamma axis, this is positive gamma, this is negative gamma. The force of m1g is towards positive gamma. The force of m2g is towards negative gamma. So the net force trying to move the system towards positive gamma is m1g minus m2g. So the acceleration comes out to be m1g minus m2g upon the total mass of system m1 plus m2. So easy. Now, once you have found acceleration and you make the force equation on anyone, either m1 or m2, you can make the force equation on m1, that there is an upward force of T1, there is an acceleration A, which we already know is m1 minus m2 into g upon m1 plus m2, and there is a downward force of gravity m1g. So we can write the equation m1g minus t1 equals to m1 into a, substituting the value of a and solving, we get that tension comes out to be 2m1 m2g upon m1 plus m2. So do we need to remember it? It will be so widely used, it's better to remember it. 2m1 m2g upon m1 plus m2. Now what will be the value of t2? If the pulley is massless and the net force on the pulley is 0, then we can say that t2 has to be equals to 2 times of t1. So if you remember T1, you already know what is T2, double of T1. So if T1 is 2m1 m2g upon m1 plus m2, then T2 has to be double of it. So that will be equals to 4m1 m2g upon m1 plus m2. I want you to remember these results for the Atwood machine. I will teach you something more related to center of mass when I am teaching center of mass. Let's move on. Find the acceleration of blocks, tension in the string and force by the support on the pulley. So this is a little different case. So now here on a horizontal surface we have placed a block of mass 4 kg and from it hangs a vertical mass of 6 kg. This time what will be the acceleration? Once you get acceleration you need to find the tension in string. Once you get the tension in string you need to find the force by support on the pulley. So what will be the force applied by the support to which this pulley is fixed? So let's see. First of all, choose an axis along the string. That's why it's called equation along the string. So let's choose this axis. Let's say beta this is my plus gamma and this is minus gamma. Now visualize the forces. On this mass of 6 kg there will be a downward force of weight. Yes. This force is towards positive gamma. Yes. On this mass of 4 kg there will be a force of weight that will be downward. What will be the component of this force along the axis we have chosen along the string? So you will say, sir, there will be no component of this force as this force is perpendicular to the gamma axis. So there will be no component of this force along the gamma axis because two mutually perpendicular directions are mutually independent. As this force is perpendicular to our chosen gamma axis, there will be no component of this force. Hence, the net driving force will be equals to 60 Newton. So we can say that the acceleration is nothing but the net driving force 60 upon total mass of system, that is 4 plus 6, which is 10. So the acceleration comes out to be 6 meter per second square. Once we have got that acceleration is 6 meter per second square, it is super easy to find out tension. You can either make equation on 4 kg or you can make the equation on 6 kg. To find tension, make the force equation on any one of the block. Let's make it on 4 kg block. On the 4 kg block, the force of tension acts towards right. And under the influence of this tension, it attains an acceleration of 6 meter per second square towards right. So you can say the net force in direction of acceleration equals to mass into acceleration. And we have already found that the acceleration is 6. So the tension has to be equals to 4 into 6. That will be equals to 24 Newton. So the tension in this string has to be 24 Newton. Now comes the last question. What is the force by support on the pulley? To find the force by support on the pulley, look at the forces acting on the pulley. So, to find the forces by support on pulley, visualize forces on the pulley. So, there is a force because of this tension, there is a force because of this tension, and let's say there is a force because of the support. Let's call it M. If the net force on the pulley is 0, then the resultant of these three forces should be 0. I have taught you if the resultant of these three forces is 0, then the resultant of any two of them should be equal and opposite to the third one. If the resultant of three forces is 0, then the resultant of any two of them should be equal and opposite to the third one. So I can say the resultant of these two forces of tension should be equal and opposite to M. Now these two forces of tension are perpendicular to each other. So their resultant will be under root of t square plus t square, that is under root of 2t square, that is root 2t. Hence we can say the force N has to be equal to root 2t. So for equilibrium, we know that N equals to root 2t. Let's see more example to understand it better. Next example. Okay, since we know that t is 24, here we can substitute 24. So the force by the support comes out to be root 2 into 24. Or we can call it 24 root 2 Newton. Moving on. Determine the acceleration of both the blocks. So here we have got two blocks, one of mass 4 kg, one of mass 6 kg. We need to find the acceleration of both the blocks. The heading I am teaching is called equation along the string. So you have to think of an axis which I call the gamma axis along the string. So let's say beta, this direction is positive gamma, this direction is negative gamma. On the 6 kg block, there is a force of gravity of 60 Newton towards positive gamma. But on the 4 kg block, the force of gravity will be downward, 40 Newton. As well as there will be a force of normal because of incline. Can you notice that the force of normal due to incline is perpendicular to our gamma axis? Two mutually perpendicular directions are mutually independent, hence there will be no contribution of this force of normal along the string. So we do not need to worry about it. But we have got the force of gravity downward 40. It will have a component along the string. How much? We know that when we have a block of mass m placed on an incline of inclination theta, then the component of force of gravity along the incline is mg sine theta. So here the component of force of gravity along the incline will be 40 sine 30. Sine 30 is half, that will be 20 Newton. So let's do it. So visualize the forces along the string. There is a force of 60 Newton. On the block of mass 4 kg, there is a downward force of 40, and you can break down this force into components. So the component of this force of gravity of 40 along the string will be 40 sine 20, and 40 sine 30 equals to 40 into half, which is 20 Newton. So here the force towards positive gamma axis is 60. The force component towards the negative gamma axis is 20. So the net driving force which tries to move it towards the positive gamma will be 60 minus 20. So we can say that the acceleration comes out to be 60 minus 20 upon overall mass, which is 10. So the acceleration comes out to be 4 meter per second square. So this 6 kg block will have downward acceleration of 4 meter per second square, while this 4 kg block will have acceleration of 4 meter per second square up the incline. If they ask you, determine the tension, then to find tension, make force equation on any one of the block. You can make the force equation on the 4 kg block. You can make the force equation on the 6 kg block. I am making here the force equation on the 6 kg block. On the 6 kg block, there is a downward force of gravity 60 and upward force of tension T. And under the influence of these two forces, we know that it will move down with an acceleration of 4 meter per second square. If the block goes down with an acceleration of 4 meter per second square, we can write the equation of force as the net force in the direction of acceleration equals to mass into acceleration. So 60 minus t equals to 6 into 4. So we can write 60 minus t equals to 6 into 4. So 60 minus t equals to 24. When you bring this 24 to the left hand side, your tension comes out to be 36 Newton. Now if they ask you what is the force by the support on this pulley, it might look tough to you to find. It's super duper easy. Now to find the force by support, look at the forces acting on the pulley. On the pulley there will be a tension here, there will be a tension here. Can you tell me what will be the angle between these two forces of tension? What will be the angle between these two forces of tension? Sir, it's easy. This angle is 30 degrees. So this angle, which is the angle between the two forces of tension, will be 60 degrees. I have already taught you, if you have got two vectors of same magnitude r and r inclined at angle theta, then their resultant comes out to be 2r cos theta by 2. Here you have got two forces of tension inclined at angle of 60 degree. So their resultant will be nothing but 2t cos 60 by 2. And the resultant of these two tension has to be equal and opposite to normal. So you will say n equals to 2t cos 60 by 2. Cos 60 by 2 becomes cos 30. So you get 2t into cos 30, and beta cos 30 is root 3 by 2. So you get 2 into t into root 3 by 2. Here in place of cos 30 you write root 3 by 2. The 2 and 2 will get cancelled. So what you get is t root 3. Substitute the value of t as 36. The force by the support on pulley comes out to be equals to 36 root 3 Newton. Let's practice more. Find out the acceleration of both the blocks. So here we have got two blocks. On the left hand side, the block of mass 2 kg. On the right hand side, a block of mass 3 kg. What will be the acceleration of both the blocks? Simple. Assume an axis along the string. Let's say this is positive gamma, this is negative gamma. On the mass of 3 kg, there is a force of 30 Newton towards positive gamma. On the mass of 2 kg, there is a force of 20 Newton towards negative gamma. Who will win? 30 Newton wanted to move towards positive gamma, 20 Newton wanted to move towards negative gamma. The 30 Newton one will win. So we will say the acceleration will be equal to the net driving force along the string upon the total mass of system. So acceleration will be equals to 30 minus 20 upon 2 plus 3. That becomes 10 by 5, which is 2 meter per second square. So we know that this 3 kg block will go down with an acceleration of 2 meter per second square, and this 2 kg block will go up with an acceleration of 2 meter per second square. If we need to find tension in string, make force equation on any one of the block. Any one. You can make it on 2 kg, you can make it on 3 kg. I have made here on 3 kg. If we look at the forces on the 3 kg block, there is a force of tension upwards, yes sir. There is a force of gravity 30 Newton downward, yes sir. And under the influence of these two forces, it is going down with an acceleration of 2 meter per second square. The net force in the direction of acceleration equals to mass into acceleration. So we will write 30 minus t equals to 3 into 2. So 30 minus t equals to 6, or t has to be equals to 24 Newton. Easy. Let's practice one more question. Find the acceleration of block and tension in both the strings. So here we have got 3 blocks and we have got 2 strings. We need to find the acceleration of the system as well as the tension in both the strings. So again, assume an axis along the string. The name itself is equation along the string. So on this block of mass 4 kg, there is a force of 40 Newton because of gravity towards positive gamma. On this mass of 4 kg, there is a force of gravity of 40 Newton, but this force is perpendicular to the axis we have chosen. And on this block of mass 2 kg, there is a force of 20 Newton towards negative gamma. So this force of 40 Newton wanted to go towards positive gamma. This force of 20 Newton wanted to go towards negative gamma. Who will win? Sir, the 40 Newton force will win. So we can say the net driving force towards the positive gamma axis will be equals to 40 minus 20. So the acceleration has to be equal to 40 minus 20 upon the mass of whole system, and the mass of whole system will be 4 kg plus 4 kg plus 2 kg, which is 10 kg. So the acceleration comes out to be 20 by 10, that is 2 meter per second square. Now to find T1, make the force equation on 4 kg, and to find T2, make the force equation on 2 kg. So to find T1, make the force equation on 4 kg. The 4 kg goes down with an acceleration of 2 meter per second square. So you will write the net force in the direction of acceleration equals to mass into acceleration. So 40 minus T1 equals to 4 into 2. 40 minus T1 equals to 4 into 2. So beta T1 has to be equals to 32 Newton. To find T2, make the force equation on the 2 kg. So on the 2 kg, there is an upward force T2, there is a downward force of gravity 20, and it goes up with an acceleration of 2 meter per second square. The net force in direction of acceleration equals to mass into acceleration. So T2 minus 20 equals to 2 into 2. T2 minus 20 equals to 4, or T2 comes out to be equals to 24 Newton. Let's practice next example. Determine the acceleration of block and the tension in string. So here again you have got 3 blocks, a block of mass 1 kg, 4 kg, 5 kg. You need to find the acceleration of all the 3 blocks as well as the tension in the string. So again assume the axis along the string. It's called equation along the string. Positive gamma, negative gamma. On the 5 kg, there is a force of 50 Newton towards positive gamma. On the 4 kg, there is a force of gravity downward 40 Newton, but it will have a component along the axis you have chosen, and that will be equals to 40 sine 30. 40 sine 30 is 20 Newton. And on the 1 kg mass, there will be a force of gravity 10 Newton. Notice that this component of the force of 40 Newton tries to move it towards negative gamma. This force of 10 Newton is also trying to move it towards negative gamma. So these two forces, 10 Newton and the component of the force of 40 Newton, are trying to move it towards negative gamma, while the force of 50 Newton is trying to move it towards positive gamma. Who wins? Sir, this 50 is single-handedly stronger than the combined effort of this 20 Newton and this 10 Newton. So find the forces along the string. You will say that the acceleration will be equals to 50 minus 40 sine 30 minus 10 upon the overall mass of system, which is 5 kg plus 4 kg plus 1 kg, denominator is 10 kg. Sin 30 is half, so this 40 sin 30 becomes 20. 50 minus 20 minus 10 gives you 50 minus 30, which is 20. So you get 20 by 10, which is 2 meter per second square. So this is the acceleration. Now to find beta T1 now, make the force equation on 5 kg, and to find T2, make the force equation on 1 kg. To find T1, we are making the force equation on 5 kg. We will say the net force in direction of acceleration 50 minus T1 equals to 5 into 2, which is 10. So T1 comes out to be 40 Newton. To find T2, make the force equation on 1 kg. You will say that the upward force is T2. The force of gravity is 10 Newton. It has got upward acceleration of 2 meter per second square. The net force in direction of acceleration, the net upward force equals to mass into acceleration. So T2 minus 10 equals to 1 into 2. So T2 has to be equals to 12 Newton. Okay. Let's see the next example. Find the acceleration of block in each case. And this is the last problem. So first case, second case, third case. What will be the acceleration of the blocks in each case? In the first case, if we assume the gamma axis, and let's say this is positive gamma, this is negative gamma, a force of 2 mg towards positive gamma and a force of mg towards negative gamma. So the net driving force towards positive gamma is 2 mg minus mg. The mass of the system is 2m plus m. So in the first case, you will say acceleration to be 2 mg minus mg upon overall mass of system, that is m plus 2m, that is 3m. So you get mg by 3m. So the acceleration comes out to be g by 3. So this 2m has got downward acceleration of g by 3, while this m has got upward acceleration of g by 3. Now, in the second case, we have applied an external force of 2 mg and the body has a mass m. Again, assume the gamma axis. This is positive gamma and this is negative gamma. The force of 2 mg want to move it towards positive gamma, and the weight of this mass mg will try to move it towards negative gamma. Who will win? Definitely 2 mg will win. So we will say the acceleration in this case will be 2 mg minus mg upon mass of the system, and this time the mass of the system is only m. So 2 mg minus mg upon m. So the acceleration comes out to be mg upon m, that is g. So this block will go up with an acceleration of g. And the last case, here we have got two blocks, both have mass m, but on the right block we have applied an additional force of mg downward. So again, if you think of the equation along the string, this is positive gamma, this is negative gamma. Here an external force mg, here a force of gravity mg, and here a force of gravity mg. These two forces, the external force and the force of weight on the right block, are trying to move it towards positive gamma, while the force of the weight on the left block is trying to move it towards negative gamma. So the net acceleration has to be equals to 2 mg minus mg upon overall mass of system, that is m plus m, 2m. So you get this mg and mg get cancelled, mg by 2m. So the acceleration has to be g by 2. So this one will go up with an acceleration g by 2, and this one will go down with an acceleration g by 2. In the next lecture, we will talk about spring and pseudo force. So see you guys in the next hour. Bye bye. So that's all for now. See you guys in the next hour.